In the second part of this problem, we're asked to use the Taylor series for f about x equals 0 in part A that we just found to determine whether f has a relative maximum, relative minimum, or neither at x equals 0, and give a reason for your answer. So just the basics, how we determine whether a function has a maximum, a minimum, or neither at a particular point is we use the first derivative that has to be 0 or does not exist. But in these cases, the derivatives all exist here. So we're looking for the first derivative to be 0. And ordinarily what we do is we do a sign chart at that point, which is a little difficult to do with series. But what we can do instead is to do a second derivative test, which is to check to see whether or not the second derivative is positive or negative at x equals 0, and that'll tell us whether we're concave up or concave down, and whether we have concave up would be a minimum, concave down would be a maximum. So let's take a look at how this plays out. So I've started with a copy of the Taylor series for f, which you can see there, which we found at the end of part A above. And I'll just make a note that that is f of x. The infinite series is equal to f of x. Now, we want to know if there is a 0 derivative when x is equal to 0. So we'll need to find the derivative of this. And so we'll take the piece by piece or term by term derivative of that series. The first term will be 0. The second term will give us 2x over 4 factorial, then minus 4x to the third over 6 factorial. And we don't even have to go any further than that. We're not asked for the general term or any specific number of terms. But we can see that now when we take f prime of 0 and plug in 0 for all of those x's, we will in fact get 0 there. So we definitely have a stationary point there. Is it a minimum, a maximum, or neither? We're going to use the second derivative test for that. And so we'll take the derivative of the first, which is just 2 over 4 factorial, and then the derivative of the second term would be 3 times 4 times x squared over 6 factorial. And I'm not going to take the time to even multiply all that stuff out. But one thing that I do know is that when f prime prime, when x is equal to 0, f prime prime of x will be 2 over 4 factorial, which is 1/12, greater than 0. And so f of x is concave up, and f of x has a minimum at x equal 0. And that's all we need for part B. And I will just stop it at that point. So again, what we did was use the second derivative test. We took the first derivative, made sure that was 0 when x is 0. Then we took the second derivative to see whether that was positive or negative when x is equal to 0. Positive would mean concave up, and we'd have a minimum. Negative would mean concave down, and we'd have a maximum. All right, I'll go on to the next part in the next video.